Can we add or subtract two different vector quantities? Vector quantities like displacement and velocity. Or can we add velocity to acceleration? It doesn't make any sense to add or subtract two different physical quantities. But what about the product or multiplication of two different vector quantities? Then answer is yes. There are two types of result when you have a product of two vector quantities, the scalar or a vector. These two different type of results is because of two different type of product or multiplication of vector quantities. One is known as dot product. For example, the force dot product with displacement vector. It gives you the result as a scalar quantity known as work done. But if you multiply displacement as a cross product with force, it will give you another vector quantity known as torque. The first one is the dot product and second one is the cross product. In today's session, we'll talk about and understand the different aspects of the dot product. What is dot product? Let's take, there are two vectors, vector A and vector B at angle theta. Then the dot product of A and B is given by AB cos theta. Now this AB cos theta can be written in two different ways. First one, A multiplied by B cos theta. Now this B cos theta is the component of B in the direction of vector A. This can be find out by putting a perpendicular from the head of the vector B to the vector A or extended line of vector A. In this case, this line gives B cos theta, which is a component of vector B in the direction of vector A. Now, in another way to write down the same thing is A cos theta dot B. In this case, A cos theta is nothing but the component of A in the direction of B. Here, this length is A cos theta. So basically the dot product is the multiplication of magnitude of a vector and the component of another vector in that direction. Dot product in its nature is a commutative. What does that mean? It means the sequence of multiplication of two vectors doesn't make any difference. So A dot B is AB cos theta, B dot A is also AB cos theta. So we can say vector A dot B is equal to vector B dot vector A. Now what is the dot product of two vectors when vectors are perpendicular to each other? For example, here vector A and vector B are perpendicular to each other. So the dot product of these two vectors will be AB cos 90 and cos 90 is 0. So the dot product of two perpendicular vectors is always 0. Now let's consider three mutually perpendicular directions in Cartesian coordinate, which is x-axis, y-axis and g-axis. Here there are unit vectors in the direction of x is I cap, in direction of y is j cap and in the direction of g is a k cap. Here the magnitude of all of these unit vectors are 1. So now if we multiply any two perpendicular unit vectors, we will get the result as 0. So I cap into j cap is equal to j cap dot k cap equal to k cap dot I cap, which is equal to 0 because of theta is 90 degree in any of these mutually perpendicular unit vectors. And here the sequence of the vector does not make any difference. So we can write down that j cap I cap will be equal to k cap j cap equal to I cap dot k cap is equal to 0. So here what we understood that if we want to know if two vectors are perpendicular to each other, then we can just look for if their dot product is 0. If it is, then those two vectors will be perpendicular to each other. Now let's see if vectors are parallel to each other. Here there are two vectors, vector A and vector B, which are parallel to each other, means the angle between them is 0 degree. Then the dot product of these two vectors will be equal to AB cos 0, and cos 0 is 1, so this will be equal to AB. So the dot product of any two parallel vectors is equal to the multiplication or product of their magnitude. Now assume if both the vectors are same. For example, if I do a dot product of vector A with another vector A, it will give me the magnitude square. So magnitude of any vector can also be found out by the square root of this vector dot product with itself. Okay. Now let's check out the mutually perpendicular unit vectors I cap, j cap and k cap. So in case of dot product of I cap with I cap will be equal to j cap dot j cap will be equal to k cap dot k cap, and this will be equal to 1, the magnitude of these vectors. Now let's find out how we can use the dot product of two vectors to find out the angle between them. Here there are two vectors, vector A and vector B, having angle theta. So the dot product of A and B is AB cos theta, and from here we can find out the cos theta. So that will give us the angle between vector A and vector B. Now let's check out one example. Here find out the angle between vector A and vector B. So angle between these two vectors can be found out by cos theta, which is ratio of dot product of these two vectors divided by their magnitude. So here this will be I cap plus j cap dot product with I cap plus 4j cap divided by magnitude of these vectors. So vector A has magnitude of 1 square plus minus 1 square root of that, and the magnitude of vector B will be square root of 1 square plus 4 square, and this will result in 1 plus 4 divided by square root of 2 and square root of 17, and this equal to 5 by root 34. That means theta is equal to cos inverse 5 by root 34, and this way we can find out the angle between two vectors. The dot product also help us to find out the component of a vector in the direction of other vector. Let's see how we can do it. To do that, first we need to understand how we can find out the direction of a vector. Direction of a vector like here B vector can be given by the unit vector in the direction of that vector. The unit vector B cap is the ratio of the vector itself with its magnitude. Okay, here is the example. Find the unit vector in the direction of vector A. So here unit vector A cap is nothing but vector A, which is I cap plus j cap divided by its magnitude, which is root 2. So here A cap is the unit vector in the direction of vector A. Now let's see how we can find out the vector component of vector A in the direction of B, which is basically you can write down the component of vector A in the direction of B is equal to A cos theta B cap. A cos theta gives you the component, which is this one 90 degree here. The A cos theta is the magnitude of component of vector A in the direction of B, which is multiplied by direction of B, gives you the vector component. And here cos theta can be written as A dot B divided by AB and B cap as it is, and this will cancel out, and this can be also written as A vector A dot product with unit vector B and then B cap. See, this particular expression is nothing but A cos theta. Okay, so we can find out in any of these two ways. Now let's find out the vector component of vector A in the direction of vector B. Here that will be A B, which is a component of vector A in the direction of B, can be written as A cos theta B cap. Here the magnitude of vector A is 3 square plus 4 square, which is square root of 25 equal to 5. Similarly, the magnitude of B is square root of 1 square plus 4 square, which is equal to square root of 17. Here the A dot B can be written as 3I cap plus 4J cap dot product with I cap plus 4J cap, and this is equal to 3 plus 16 equal to 19. So the cos theta, which is nothing but A dot product B divided by AB, which is 19 divided by 5 root 17. And B cap is given by vector B I plus 4J cap divided by its magnitude, which is root 17. So the component of vector A in the direction of B can be written as magnitude of A, which is 5, then cos theta, which is 19 divided by 5 root 17, and the B cap is I cap plus 4J cap divided by root 17, and this is equal to 5 cancel, so it is 19 by 17 I cap plus 4J cap, and that is what the component of vector A in the direction of vector B. Here the example number 4, where a force is 3I cap plus 4J cap is working on an object that result in object displacement of 10 meter in x direction. What is the work done by the force on that object? The work done is nothing but the dot product of vector F and the displacement vector D. Here displacement is 10 meter in x direction, so 10I cap. Okay. So W can be written as the dot product of these two vectors, which is 3I cap plus 4J cap multiplied by 10I cap, and this is equal to 30 joules. Another uses of dot product is to find out the magnitude of a vector quantity. We know that the dot product of any vector with itself gives the square of its magnitude. So magnitude of any vector can be written as a square root of dot product of that vector with itself. Now let's see an example. If dot product of vector to itself is 100, that is mean A dot A is 100. So what is the magnitude of that vector? Here we know that A dot A is equal to A square. So the magnitude of the vector is a square root of A dot A, which is a square root of 100 in this case. So magnitude of A is 10. Okay, and that is what the answer. So in this way we can find out the magnitude of a vector by using a self dot product. Now it is a time for questions for you. There are 2 questions this time. Put your answers in comment box. And that's all we have for today's session. I hope you would have enjoyed this. If you think you have learned something new today, then please click like button and subscribe us for similar type of videos. Thank you for watching. See you next time. Bye.